back. Good evening. Uh, First off, we're going to be talking about the ALU, but before that, let's have a quick discussion about something called latching. I know I've probably mentioned it a couple times previously, but to latch means to capture something. In this case, latching refers to the CPU component getting a value from the bus. And this only happens if the component's in control line is enabled and a clock pulse has occurred. That is, the value from the bus doesn't immediately go into the component unless it's enabled. This is a critical idea to understand. Basically, the CPU needs the ability to control when values are brought into a component. It needs a time for some component to output its value to the bus, and then another time for a component to latch it from its input and get that value. And that's what subsequent clock cycles are for. One component puts it on, a clock cycle occurs, and then another component reads that in. But it should be noted that a component's output, when it's enabled, it goes immediately to the bus. So it doesn't have to wait for an output to go to the bus. It doesn't have to wait on the clock cycle. But basically, all the inputs are latched only on the rising edge of the clock pulse. That's when the clock pulse just begins. We'll show that shortly. So we need to get our minds around what's called the ALU, or the arithmetic logic unit. This component is basically the calculator within the CPU. In the case of the SAP1, unfortunately, it can only add and subtract. It's very basic. So where are we going to get these values to add or subtract? Those are going to come from register A and B. And so you might ask, well, what are registers? We haven't really talked about that yet. So registers are special. It's a special type of memory, and really not that much different than RAM. But only in this case, there's just a single 8-bit value. And we see register A here, and we have register B here. So they basically store a value until they're overwritten by another value. So they're going to kind of a temporary RAM kind of thing, but they just have a single, in our cases, have a single 8-bit value. In most cases, registers have an in and out control line, as you can see register A does. But on the SAP1, the B only has an in. And that's due to the limited nature of the CPU, and for examples, we don't really need them. But in a real CPU, they would, all the registers would have some kind of in and out. So you'll notice that the ALU component has some kind of little funky character, and then an O, and then an SU. So that funny little character is the Greek symbol sigma. You may recognize that from programs like Excel, and basically it's the mathematical symbol for summation. And again, S is for summation. But Ben uses this notation in his video, so I just kind of kept it in there so that to create some familiarity if you're using this emulator with his video. The summation out, or sigma out, basically causes the value within the ALU to go to the bus. The SU control line, well, I guess it's really not I guess it's sort of a control line, but it basically tells the ALU to subtract versus add. So all right, well, let's get this thing going, and let's add 28 and 14 to get 42. We have our RAM values still in memory. So you can see that address 0 has the 28, and address 1 has 14. So we're ready to go. So if you don't have that, the previous video will help you get that set up. Okay, we'll go ahead and hit the reset button. And so for RAM values, if you reset, you won't lose your RAM values. But if you power it on, or if you refresh the browser, the RAM values will go away. That's the way RAM works. If you lose power, it goes away. It's the difference between RAM and ROM. All right. So now let's go ahead and press the halt to stop the clock from blinking. So we're basically going to go through and set the control lines manually and kind of step through, basically make our CPU add these two numbers together and end up with our items in the output. So we're going to basically do all the work. Okay, so the first thing we need to do is we need to enable Mars MI, the control line, and then enable the program counter CO. Okay. And then we want to pulse the clock. And so what's going to happen is we have a 0 value, and it's going to go to the bus, and then that's going to go to RAM's address value. Now, you're not really going to see anything because it's all 0, and this guy is already 0. So when we pulse the clock manually, we saw something here, but we really didn't see anything happen because basically, we were already sitting on 0. So the value that we're interested in is in RAM. So we need to disable all the things we enabled previously, and then we need to enable the PC's CE, so clock enable. So the next clock pulse will increment, and that will prove useful. And then we want to enable RO, and then when you do that, you see that the value in RAM, which is the 28, has been copied to the bus. And then we want to bring that into the A register, and so that's going to be an A in. See, we see no value yet because that's going to wait on a clock pulse. So upon pulsing the clock, then we see the value has come into A. So, and you also see in the ALU that it's already added register A and B together. Register B is 0, and so of course we'd see the same value in A as in the ALU. So that is immediate. The minute a register changes, the ALU will reflect what it's supposed to do. Right now it's not in subtract mode, it's in addition, so it's immediately, it doesn't have to wait like for a clock or anything. It just, whatever values are in A and B, that's what it's going to work on. Okay, so then we need to basically disable all the things. And you notice that on that clock pulse, we really had two things that occurred. Number one, we had the value come into register A, and we also had this guy incremented. So the next thing we need to do is we need to enable the output here. We're going to enable the in, right? And then we're going to say we have everything disabled. We're going to pulse the clock, right? And then so we brought in memory address 1 here. We have a value of 14. So that's good. So we didn't really need to do the program counter because we don't need the value of 2. So let's disable these things again. And so we're going to output this value to the bus, and that happens immediately. And then now we're going to bring the second value into B. Of course, no transfer yet. We have to wait for a clock. So then we pulse the clock. Boom. We have the value brought into B, and our answer is actually already in the ALU. So this should be 42. Should be. So we're going to disable the things we had enabled. And now we want to bring this value into the output. So summation out goes to the bus, and then output in. So we really haven't talked about this guy yet, but he's just a simple display, and he's going to take his value from the bus and display that on once again, this is an input that's going to happen on the next clock cycle. So we pulse the clock, boom. There's our magic answer, number 42. And so those are basically the steps that we're going to try to automate in later videos. But this shows that you can set these things manually, step the clock, and this is what the CPU does automatically. So congratulations are in order. You probably this is probably the most complicated way you could add two numbers together. But that's what the CPU does. It just does it very fast and without complaining. So this procedure is really just a baby step in our overall understanding. Hopefully you'll see how these things are coming together. If you have any questions, definitely post some comments. Hopefully I explained it well. Kind of the main purpose of this exercise is just to get you interacting with the CPU because in the next we're going to have to get into instructions, and fortunately it gets a little more involved. I think the next things are pretty interesting, but make sure we have a good understanding of what's going on here first. And so we've set the control lines, we've pulsed the clocks, we've seen how information flows out of one component into another, and it's all kind of a very step-by-step procedure. Let's see, I think that's it. So hopefully there's no outstanding questions. If so, leave some comments. Thanks. Have a good evening. Good night.